Today we see about dynamics machines. Actually, it's extracted from the kinematics of machinery, the next version of kinematics of machinery. So, what is the difference between kinematics of machine and dynamics of machines? Then, kinematics of machine means the object in motion where the forces acting on the object or machine were not considered. That is kinematics of machine. Whereas in dynamics of machine, the object in motion, we have analysis the what are the forces acting on the component or machine or equipment, whatever may be. These are the things we have to see in our upcoming sessions. So one by one. So this is the major difference between the dynamics of machine as well as the kinematics of machines. So so the kinematics of machine is the fundamental one. We studied each and every node of the terms in kinematics of machines. The next version we can see in dynamics of machine. This is a major thing here. So some of the real-time applications here. So the application of every day and everywhere. All machine work when a number of mechanisms work in tandem. Dynamic loads and undesired oscillations increase with higher speed of machines. The industrial safety standards require better vibration reductions. If you go with much vibration, the total system get collapsed in a particular period of time. So the example is engine and power plant. So these are the things we have frequently used and analyze the things. Then the overview of the subject is the theory of machines may be defined as the branch of engineering science which deals with the study of relative motions. The relative motions, so one of the motion depend upon the another one. So there is the relative motions between the various parts of the machine. The machine components have plenty of components which are interlinked. So the movements may be one of the movement of the component depends upon the another component. So this is the thing we can specify as relative motion and forces which act on them. So what are the forces acting on them? So we need to analyze such things. Why this subject? The knowledge of this subject is very essential for an engineer in designing various parts of the machine. So in design aspect we need to study these things, then only we can access. Otherwise it's very difficult to design a component, equipment, whatever may be, whether it may be stationary or in a motion one, but we have to analyze the things in an efficient way. So the theory of machines. So first it is the force analysis. So analysis of force. So there is plenty of forces available. So especially what are the forces acting on the machinery depend upon the for motion of an object. And what are the forces we apply, like which the object get its operation. So these are the things we need to consider. So theory of machines, it have categorized into dynamics and kinematics. Then dynamics may be classified as kinetics and statics. Where kinetics, the term generally the dynamics means the object in motion, whereas in kinetics the object in motion. So both the kinetics as well as statics. So depend upon the motion we can categorize like nice. So the kinetics which specifies the forces to be considered in a system. that is kinetics, where the object in rest or stationary position we call it as statics. Dynamic analysis in reciprocating engine, the analytical methods, the motion of crank and connecting rod of reciprocating steam engine as shown. So the length of the system PC is the connecting rod, OZ is specified as a crank. Due to rotation of the OC, the PC will move or it generate the reciprocating motion. So whereas the rotary motion converted into reciprocating motion. So these are the major things here. Then flywheel of mass m kg. So radius. So angular velocity radian per second. So these are the things happening. It's a rotary motion here. So flywheel we have only the rotary motions acquired here. The subject theory of machines defined as a branch of engineering science, a study of relative motion between various parts of an engine and forces which act on them. It's very essential for engineer in designing the various parts of the machine. So the design aspect is very essential, and it's necessary to move forward. So what are the subdivisions of theory of machines? The theory of machines may be subdivided into following four such branches. Then kinematics, dynamics, kinetics and statics. Kinematics means the object in motion where pressure forces are not considered. Dynamics, the object in motion where forces are, we can simply say the object in motion. Then kinetics, the object in motion where pressure forces considered. Then statistics, the object in stationary one, so that is we called as statics. So this subdivision of theory of machines. So kinematics, as we discussed in earlier, the theory of machines deals with the relative motion between the various parts of the machines. Then dynamics, this is the branch of theory of machines which deals with forces and their effects while acting upon the machine parts in motion. So this is the dynamics here. Then kinetics, so it's a branch of theory of machines, deals with inertia force which arise from the combined effect of the mass and motion of the machine parts. Then statics. So statics means, so theory of machines deals with forces and their effects while the machine parts are at rest conditions. The masses of the parts seem to be negligible one. So these are the wide category of dynamics of machines here. So that is very essential to understand the concepts in dynamics of machines. So without this knowledge we can move forward, but the knowledge we are acquiring in an upcoming classes, it's very difficult to access and it generate plenty of doubts at all. So we have to be very strong with our fundamentals, then only we can survive better in upcoming days. So that's why we are crossing these concepts. So acquiring these concepts and the knowledge about their concepts as well as the relative motions acquired in between the components, that should be ensured. So that is the major things here.